Hi everyone, I'm Victoria Alvin from Kingspan Thermakraft. I'm the General Manager for Building Technology and Technical Services. My name is Victoria Alvin and I'm presenting today on cost-effective continuous insulation design. Just going to hold there for a moment. We've actually got quite a good subscription to this webinar today. And in previous experience, we know that we just need to leave it a minute to allow people to get in so we don't get internet crash and so on out of it. So we're just going to hang in the space and I'm going to awkwardly fill for a moment while we wait for our numbers to load in so we don't crash out for them. Okay, that looks like we've stabilized relatively well. That first flush is in. So for those that have just joined us today, my name is Victoria Alvin. I run the technical team here at Kingspan Insulation, which is also Thermakraft here in New Zealand. And this is our last Kingspan Digital Academy for this year. So thank you for joining us. Today's topic is cost-effective continuous insulation design. What we're going to be looking at today is mitigating thermal bridging, how to use continuous insulation, and of course, looking at some of the ways it can save you time and money in your build. But who is Kingspan Thermakraft? Well, Kingspan is a global company. We're I think we're the seventh largest company in Ireland. And in 2021, we bought Thermakraft, which is a New Zealand manufacturer of underlays here in New Zealand. We are well known throughout the world for our PIR, polyisocyanate insulation, which we started making in 1965. So Kingspan is considered one of the global leaders of PIR. But we also make phenolic insulation, which is a slightly different type of rigid insulation product I'll be talking to you about today. When we look at different insulation products, this is the key point that I want you to remember today. They don't all provide the same product R value in the same thickness. So here on screen, you've got quite a variety of different types of material to insulate your projects. Out on the right-hand side, you have polyester there and fiberglass. Now, we were looking at the thickness that's required to meet R2.8, and you can see these thicknesses are quite high, 180 mils, 160 mils. It's a different type of insulation, an open fiber insulation. When we come over to the left-hand side of this graph, you can see we have phenolic insulation and PIR insulation. These are both closed cell rigid insulations. And if I've said Kingspan is one of the global leaders of PIR, that's still very efficient in the height that you need to get an R2.8, about 70 mils. But phenolic is even more efficient insulation. So slightly better fire performance and more efficient at 60 mils product thickness to meet R2.8. So the types of products that we're mostly talking about today, phenolic insulation, mean that we're looking at very high R value performance and very thin thickness. So we use those in applications where space is at a premium and R value is important. The range that we have for phenolic insulation covers most applications within our market. Phenolic is made with a blowing agent to activate a catalyst in the board, and then it has faces on either side. Now, the faces that we use there, sometimes they're fire retardants, such as our K10 Safite board, where that's used on the underside of a car park. It has a Group 2S rating. And sometimes they're just foil face, such as our K7 pitched roof board in Skillion insulation, or K12 framing board, continuous to the outside of the frame. And we even make a insulated plasterboard with phenolic foam and plasterboard pre-attached, which means a very fast and efficient retrofit, which I'll be talking about a little bit more later today. One of the key characteristics of this type of insulation is that it's fiber-free. So it doesn't have the itchy glass fibers that you might have experienced before with other products, but it does create some dust as you cut it. So PPE is still required. It is CFC and HCFC free. So we don't contribute to global warming in these aspects. And as I've mentioned, very high R value per thickness. Cooltherm at 100 mils is an R4.7. So very hard to go past that in terms of performance of R value per thickness. Low flame and smoke emission, and of course, like all the Kingspan products, it's compliant to the Australian New Zealand standard 4859. That's a standard which says that we will test our insulation for the aged value at 25 years. There's quite a process to go through outlined in that standard. And then we publish that information on our data sheets at 15 degrees Celsius, which is the temperature we need to publish at in New Zealand. So you'll find Kingspan's very strong on that compliance to the New Zealand Building Code in that aspect. All of these products have Global Green Tag Class C, and they all have an environmental product declaration as well. So where can I use continuous insulation in my build? I can use it externally to the frame to mitigate thermal bridging. I can use it within my roof construction, and typically a skillion roof is ideal for phenolic insulation, where we're trying to achieve a very thin rafter construction, perhaps 190mm rafter, and insulate it effectively to H1. So perhaps targeting an R6.6 in that construction. And using it internal to the wall, often on concrete walls. It's a key product to insulate a concrete wall effectively without condensation issues. So why are we so focused on this? Well, thermal bridging that we see here in this image is going to increase the operational energy costs. I'm going to explain what you're actually seeing in that little red image there. I have to turn and mark on this slide. These are lighter lines. That's actually the timber framing transmitting the heat out from the internal building to the outside. That's why they're showing warm. And the darker patch is where the insulation is keeping the exterior cold. It's doing its job, keeping its heat in. So when we talk about thermal bridging, what you can quite clearly see here is that the timber framing is literally draining the heat out of the building through that thermal bridging aspect. Conversely, it is also allowing cold into the building. Why do we care? Well, the Brands Beacon pathway suggests that framing is actually 34% of the wall, but more importantly, in the H1 consultation that's underway, that is suggesting that there will be a mandatory 38% timber framing for calculation and modelling methods for H1. And if you recall, those changes in the H1 standard mean that the schedule method is out by the end of 2025, the calculation method comes in its place and modelling. So it's likely that they will also mandate the timber framing percentage in that aspect as well. That makes it very difficult to build a 90mm wall out of just glass fibre as we have traditionally done. So we need to be looking at different technologies, different ways of building to enable us to meet the thermal comfort that's been called. Why do we also care about thermal bridging? Because basically that timber becomes a pathway for cold, condensation, water, mold, degradation of our structure in both roof and wall, and ultimately the illness, which unfortunately a lot of our housing stock in New Zealand is well known for. Now, I know everyone actually wants to know what the cost of these type of products are, so I'm pleased that I'm able to include this slide. A couple of years ago, we asked Maynard Marks, a consultancy firm, to do some cost analysis of the construction of typical walls, looking at basic standard merchant prices. So probably not the price that you're paying in market, because I'm sure that most people have got great rebates with the merchants, standard merchant pricing and standard labour rates. As I work through this is based on a 30% framing. So these construction R values will be impacted by the change to 38% framing when it comes through as well, principally in the first two models. That first model is a 90mm timber frame with R2.8 bulk insulation between the frame. Very standard. Approximate cost is $140 per square metre. The wall's quite thin at 120 mils, and the construction R value, unfortunately, due to the timber framing, creating thermal bridging, does not meet the R2. It's at 1.84 in the model. The second option is, well, if we thicken out that wall to 140 mils and add an R3.2 bulk insulation, that's a standard way to achieve it. Yes, I'm meeting the construction R value at R2.38, but my wall thickness is 170 mils and my cost has gone up to $155 per square metre. What if we actually were able to mitigate that thermal bridging and keep the wall cost back at $140 mark? That's where we looked at the modelling with the 90mm timber frame, a very inexpensive R1.8 bulk within the frame, and 25 mils of cool therm over the outside. So that cool therm here is an R1.1 product value for 25 mils. Over the outside of a timber frame, it mitigates the thermal bridging. So my cost structure stays as per that original 90mm timber frame, Yes, the wall thickness is a little bit thicker because it does have a structural batten on the front, but the R value is really high at 2.55. That's a real value add when we start to look at the calculation method for our walls, enabling us to add more R value in the walls and perhaps less in the roof or the slab as it counts in our build. The other option is to look at a 90mm timber frame, again with our 1.8 bulk, but perhaps adding some insulation on the inside. Insulation pre-bonded with 10mm of plasterboard for the K17 insulated plasterboard. That's the most expensive at $175 per metre squared, but it's also a really thin wall at 145 millimetres and a construction R value of 2.85. Where would that count for me? That would count if I needed retail space back in my build or rentable space. That thin wall will return investment dollars very, very quickly. So it might be more expensive to build initially, but the investment dollars for the increase in floor space will be very important to us. So understanding the different types of products and how they can mitigate thermal bridging and really what they can give you in terms of construction R value, dollars and space is quite important. Just as an example, this is that standard construction with Cooltherm over the external side of the frame as a continuous layer. So timber, glass fiber between Cooltherm and underlay, and then the cladding. The batten that's here, I'll just move my mouse here, is actually a 45mm structural batten. And that's so there's no change to the fixings for the cladding. They simply stay as they are, no RFI with regard to the fixing. And that batten connection for the 45 by 45 structural batten gives us our drained cavity, but also more permanently secures the continuous insulation to the frame and has been brands tested for performance as well. So it will take cladding up to 80 kgs for that connection and design there. So a little bit of a system going. So you can see with changing the level of Cooltherm that you have on the external side of the frame can give you some very different R values, again, giving you a lot of flexibility in your wall constructions to meet the calculation method that you may need. I should also say, actually, at this point, so I didn't say, I do have Marie Mactuel and Pedro Valea, our technical team here online answering the chat. Any questions that you may have, please just pop them in the chat and we will come to them at the end of the presentation and address them on that front. To make design work easy, we have built a series of design details that are available on our website for a variety of constructions, timber with various cladding materials, brick and so on, and some steel frame and concrete details as well. You'll see it's a very standard construction. You can quite clearly see the elements there and the structural batten that's securing the cladding. So here we have K12 used as continuous insulation on the external side of the frame. It's a very clean and simple installation. There are some insulation washers just securing that temporarily before the battens go on to hold the structure. But the key focus is mitigating this very cold corner here where you can see they've tried to fill insulation in, but that is going to be a large cold thermal bridge into the building. The detailing around the window is very simple. Creating a hard edge gives a stronger window support and prevents the insulation being crushed. There's quite a variety of ways this can be detailed, but this is very common and very easy to build with. We also like the use of a self-adhesive underlay with either rigid substrates such as the fiber cement, plywood, rigid air barriers such as James Hardie, but over continuous insulation, it means that there's no piercings with screws and so on through the continuous insulation. Rain armor will simply self-adhere over, the laps will be sealed, and most importantly, it has 120 days UV exposure. So now you can carry on, put your cladding on in your time and you don't have the issues with that amount of UV exposure for both roof and walls. One of the things we often look at is continuous insulation on concrete walls. Now, here in the technical team, we do construction R values and dew point analysis for wall and roof construction. That's part of the service we offer for Kingspan products. It's free, and you can use it to show H1 performance for your builds. But what I'd like to do is just challenge some of the ways we've been building on concrete walls for insulating. I want to take you through that. Traditionally, We might have built a concrete wall and insulated it with a timber stud and frame and fiber insulation. You can see here this is an example of one of the calculations that we've done. We have a concrete block wall at 150 mils, a 90 mil wall, and you can see it's got 11.4% timber framing that we calculated there, some plasterboard, and we got a construction R value of 2.04. Now, that wall is 250 mils thick, and it actually doesn't meet the commercial requirements. H1AS2 and climate zone 3 is R2.7, 4 is 3, 5 is 3, 6 is R3.2. So in a calculation method, it's still going to contribute, but it's not going to contribute as much as you might need. That's not actually the problem. The problem is, how does this wall construction actually perform in terms of internal moisture management and what's going to happen? So the glass fiber is a very vapor open type of insulation. So here, as you can see, this is an example of our dew point analysis. If this surface is the jib or the interior lining, and we have the insulation coming through, where these two lines meet on the concrete wall, with a circle with number 3, is where the dew point will form. And so that warm air from the interior will migrate through, hit the cold concrete wall, and we get dew forming. You might be asking me, how much should I be worried? Actually, yes, you should. Because in this model, we had a litre or 1,000 grams per square metre in the worst month of the year. That's a lot of water to form against a concrete wall. It will simply soak into the timber, the glass fibre, and pool at the bottom. And that's where we get the mould and the degradation of the structure that we've been talking about earlier. Why do I know that's a problem? Well, if I look back at the British Standard 5250, that looks at the practice for control of condensation in buildings, you can see that by the time I get to 250 grams of water per square metre, those droplets are large enough to drip from a horizontal surface. We had 4 times that on a vertical. We know it's simply going to run down the wall and be a problem. So what is the option? The option is using something like a continuous insulation Cooltherm K12 framing board on the concrete wall, direct fixed to the concrete wall, and that gives me a higher R value at 2.88 R value. In this model, we use 50 mils of Cooltherm K12, and then a clip and channel system that went over the front to create a small surface cavity, and the gypsum plasterboard. The wall insulation, or the total wall thickness, is thinner at 238 mils, so saving 12 mils off the wall, and no condensation on that model. This product is very vapor retardant just by the nature of the product, so we don't get that same movement of water through and condensing on the concrete wall. So a thinner construction, a higher R value construction, without the risk that we've seen in traditional construction methodologies. This is an example of one of the details that we've built for that on a block wall. You can see the clip and channel marked there on the left, and this is a model that we have in our office, just enabling you to visualize that and bring it to life, where the base of the channel, that's a BG clip, is simply fixed to the wall, the insulation piece fixed over it, and then the channel is holding it in place to secure the interior lining material, Aqualine, jib, whatever it is that you wish to use, and there's a little service cavity there to run the electrics through as well. For insulation that's much thicker, we might need to look at other ways of installing the continuous insulation. Again, the continuous insulation is still going hard up against the block wall, but some of the clips that are in, for example, the Rondo range, will not accommodate the larger thicknesses of insulation. So this methodology, where now battens are installed in front of the Cooltherm through to secure it into the concrete wall, give not only securement of the insulation, they actually give a structure upon which you can hang kitchen cabinets, TVs, large mirrors for hotels and so on, a service cavity that you might need for other aspects, and then you can put your interior lining material on the front. So that's a very common technique for securing continuous insulation to the wall. This is what a great example of continuous insulation looks like. In the image on the left, you can see that the board joints have been taped as well for better vapor control. And on the image on the right, the clip and channel system here, or the channel system has been put on, ready for the interior lining to be added on next. It's a very nice, clean, simple finish, and you can see why it's called continuous insulation. But we do ask that people look at the plans and don't just go through with what they've considered to be a traditional building technique, because this particular example was one where the project was specified as continuous insulation, but in this instance, the builder carried through and built a timber stud and frame. Not only did he add a lot of labor and cost to the build, he actually really changed the thermal performance of that wall, because now there's a significant amount of thermal bridging, a lot more labor cost, and a delay to the project schedule. So we invite you, if you are not sure how to install continuous insulation, one of our area sales managers, our technical teams, our specification teams will visit you on site, conduct teams training, whatever it is that you need to make sure that you understand how these products go in to meet the cost expectations and performance expectations of that project. If you don't need a service cavity and you just have a large concrete wall to fill, it's really hard to go past an insulated plasterboard on phenolic insulation like K17. It quite simply is just sticking directly to the concrete wall, and then all you have is your wet trades to finish the wall. It can be mechanically fixed, it can be adhered fixed. The construction R values are high, and it's a Group 1S rating. So it gives you that interior surface finish that you need as well. And it's a very, very thin wall construction. You can see here the mechanical fixing method. It follows the jib method. This is actually jib that's on there, a 10mm jib board that's on the front for the plasterboard. So the mechanical fixings follow the jib guidelines, and we have a construction adhesive bonding method with a polyurethane non-solvent adhesive. So blobs that are set through, and then a couple of mechanical fastenings mid-board just to hold that secure, that will sit within the taped edges. What about a Lockwood home? What about renovation? Well, this actually was my first type of home, a standard Lockwood home. And those of you that have owned them will know that there is no insulation in these walls whatsoever. And adding insulation through a cavity method while the cladding is kept on, it's just not really an option. This is where an insulated plasterboard again comes to the fore, because directly over that wood finish, the K17 goes on, and it starts to look like so. Now the window frame is going to be built out a little bit wider for your cup of tea to accommodate the thickness of insulation. And whilst this is a very thick piece that I'm holding, we do have a 35mm, which includes 25mm of insulation, 10mm of plasterboard, that also has bracing requirement or bracing performance characteristics that we'll be putting out in market shortly. So adding a 35mm of K17 will give you insulation value, some bracing values, and it's just a small amount of building out. That means that we can now insulate the wall and the ceiling easily in this type of home. So ideal for renovation for those that are building online or perhaps slightly DIY. We can also use this under to add more insulation in a skillion roof. Perhaps if that skillion roof again is in the retrofit and the roofing material is not going to be removed, we can add insulation to the underside, replacing that ceiling, either just straight over the existing jib, or in a new build, it might be on a clip and channel system underneath the rafters. Again, giving excellent construction R value, but in this instance, we're now taking a little bit of the floor to ceiling height. So there's always a little bit of balance. That is where our technical team, specification team can certainly help, talking through what are the key requirements for your project in terms of height, capacity to make changes within the build, and recommending construction techniques that will help you save the most space and give you the most efficient construction. When we look at skillion roofs, those that joined us recently for our roof condensation webinar will know that skillion roofs are often considered risky roofs because there's not a lot of roof space to allow moisture to move out of that roof, especially if the ventilation is compromised. Using K7 pitched roof board within the rafter means that I can have a very high R value within the rafter, or as you see in the image here, continuous layer over the rafter, mitigating the thermal bridging for the rafter. It means that, if I put an 80 between the rafter and 80 mil over the rafter, I can hit a construction R value of 6.7. That's fantastic. That's a really easy way to build and to keep the height of the building down. In this image, a counterbatten system has been used where a structural batten goes up the rafter and then the purlin sits over for the roof to be secured in. The placement of the purlins is naturally dependent upon the wind zone that you're in and the performance of the roofing material that's going to be screwed through to it. But this is a very common construction and very easy and fast to do. We often, again, see this in the type of retrofit construction, particularly on projects like this, which is again is a Lockwood style roof. This was actually a government housing project. It's a retrofit that was done with some sarking that was set below. So you can see the old bituminous black paper that is in the process of being removed. The tenants are still within the building. This is all conducted in one day, so no disruption to the internal tenants, but we're looking to add thermal comfort. So the old roof is coming off, the bituminous paper is coming off. Here, they've simply sprayed out the electrical lines so they didn't run a drill through them or fixing. But I'll note that phenolic insulation will not damage the electrical cables, will not plasticize the sheathing as, say, an EPS insulation will do. So you could chase out the back of the K17 to accommodate an electrical cable if required to. So it won't damage that. Of course, you do need to have the same space that you would have around any electrical cable. So here the insulation is going over the sarked roofing. The cables have been marked out. The counterbatten system is come onto the roof. I'll note as well, you can see that he's using that counterbatten system as a roof ladder. We don't know how strong the sarking is to support their weight, but certainly the cool therm is not substantial to support somebody's weight. So the counterbatten system acts as a good structure. And here the CoverTech 407 has gone over the top. Now, I'll note as well, in the coming year, we will be increasing the amount of time that CoverTech 407 can be left exposed to on a roof. So currently it's 7 days. We'll be bringing that out to 28 days in the new year. So giving a little bit more time to get roofs on where needed. But ultimately, we want the roof on same day. And in this aspect, the roof was added on that same day, completing the project. We have a white paper that's launching shortly, which is looking at the thermal comfort that's added to a skillion roof. This is the modelling for the roof we've just been looking at. So you can see here there's steel sheeting, CoverTech 407 as an underlay, the 90 mil, 245 mil counterbatten's been used, and only 50 mils of the K7 insulation on top of a 50 mil sarking. That had a construction R value of 2.97, which is really great. For just adding 50 mils of insulation and keeping that height down. I will note as well some of the feedback I've been given about this roof as to why it was chosen to do in this manner was that the repitching of the roof to accommodate glass fiber insulation was approximately $40,000. So adding K7 meant the roof didn't have to be repitched and the project was completed within that same day. So to summarize our presentation today, Kingspan offers high R value, thin thickness phenolic insulation, which will save space within the build, increasing your return on floor space. It offers mitigation of thermal bridging, more floor space, return on investment, and higher performance building, reducing the operational carbon that we get through heating our buildings and having it going out of the building through thermal energy, creating more thermal comfort for our occupants as well. Here at Kingspan, we can give you the thermal performance calculations and the dew point analysis of your construction for your project. It's a free service. We just need the build-up of how you wish to use Kingspan on that project. And we can also help you with detailing and construction advice around your project to make sure that you can tender accurately and truly reflect the savings that you're going to have on installation and labour costs. If you need help, we're here. We're technical at kingspaninsulation.co.nz. You can call us on 0800 806 595. That's our last webinar for this year. There will be a recording that comes out of this webinar, but now we can take questions if you have any online. Marie, do we have any questions?
Yes, a couple of questions. Okay, I'll first start with Wade Morris. When designing hybrid walls, the rule of thumb is one-third bulk and two-third high density to avoid the risk of condensation. Your designs do not appear to follow that rule. Are these build-ups modeled to ensure there is no risk?
Actually, that's a really good point. We do have a white paper that is on our website at the moment that is talking specifically about woofing modeling that we did for mold generation within these constructions. So looking at the likelihood of interstitial condensation between the rigid insulation and the glass fiber insulation, and then what the outcome is for mold generation between those. So you'll enjoy that read. I'll ask the marketing team to include a link to that white paper as well for you. So yes, we have done woofing modeling on these constructions. We do the interstitial condensation modeling here in this team. If we see an issue, we will be discussing it with you as well to say, hey, the balance between insulation might not be right, or this construction is slightly different. So yes, we do address that.
Yeah, might as well tackle all of the dew point questions.
All
Where
right.
is the dew point on the K12 insulation on the concrete wall? Does it occur on the face of the K12 in the surface cavity?
K12 on the concrete wall on internal insulation. In the model that I had on screen, our analysis showed that there was no dew point forming on the surface of the concrete wall because that is such a vapor retardant product and it just slowed that heat transfer down. So when it got to the concrete wall, it's not creating that condensation point. Those lines of thermal and dew aren't meeting. What we did find is that in the more vapor open construction materials, such as polyester glass fiber and so on, that did create a dew point at that concrete wall. Now, I'll be quite specific on that. Every project is slightly different in terms of the way it might be modeled and some of the performance characteristics. We put these up as generalistic of examples that we've used for some projects. We want to model your project specifically and give you that risk portfolio for your project and then discuss through if there's any changes that need to be required in terms of the balance of products.
Okay, next, what cladding weight applies to 90 mil wide cool therm insulation option? Council will ask.
So the brands testing that we did for the 45 mil structural batten was factored up to a 80 kg cladding. So I believe that will still include an aerated concrete panel on that construction. So we do have a brands test for that is available on our website and that is referenced also in our construction details as well. So that will cover your weatherboards, steel claddings, as I say, aerated concrete with a plaster, um, and then we have other details that sit around brick veneer as well, which might be heavier. Does that answer that question? Please just, if I haven't answered it, just add some more text in there.
Can the external cool therm be used for rain screen claddings rather than normal cladding?
Rain screen claddings, I always want to see the details and understand specifically what is that rain screen product and how is that application designed. We have a variety of different products with different faces for applications with cool therm. We do have a product that has a particular facer, which is great for rain screen. I personally prefer to see rain armor applied over the front of the cool therm if it's used externally to a concrete wall, because that now gives me full UV protection and weather protection. So the insulation is not going to get wet or be damaged whilst we wait for the cladding to go on. And often when it's a brick veneer, it might take a couple of months for that to be built and fully enclose that wall. Or if it's a more open construction, we would look at the type of materials. We have quite a range of products within our portfolio. And so it might be that cool therm might not be the most appropriate product. We might be moving to some other products which are more appropriate for that type of construction.
Yep, and then can cool therm and the structural battens be fixed over the face of existing claddings to provide insulation to existing uninsulated walls? Um, Typically, sheet fiber cement, hardy plank, or old timber weatherboard. How does this affect the dew point?
That's a really good question. Normally, I would like to see exactly what that buildup is and model it to be able to discuss the dew points specifically for that. If I take it as a general question, could I, if I had a fiber cement product, could I put cool therm over the outside and basically rebuild my wall out from there? Theoretically, yes, I could. Yes, I'd like to really understand what that wall construction is. And as a designer, you would also be looking at the structural performance of the wall. Can it take that weight? What will happen to it as it builds forward? Theoretically, yes, but I'm always going to want to get specific on that particular design because it can be so many different things.
What research has been undertaken to account for fixing of cavity patterns through something like 50 mil Cooltherm? I think you've also answered this already. I know dwangs are indicated, but these are largely being removed as part of a thermal bridging strategy. Can fixings be to studs?
Yes. So in the instance where the cool therm is over a timber frame, the cool therm is fixing through to the frame and the structural batten sits on the front. Now we say structural batten because if it's just like a 20 mil cavi bat, then the cladding fixing needs to change to come the whole way through into the cool therm. And that can mean that now we're in an engineering conversation about the cladding fixing. So it's not to say that you couldn't put a 20 mil cavi bat over the front. It's just that now, as a designer, you're working with a lot more engineering to make that construction technique work. The reason we chose to put a 45 mil structural batten is because then the cladding fixing remains the same as the cladding specifies into that structural batten. That structural batten secures back into the frame, and we have a secure and complete system with a drained cavity. Very easy in terms of compliance on that front. Again, if you have an alternative construction or you'd like to talk about doing things in a slightly different way, we'll work very hard to find you a compliance pathway, but we'd look specifically at that detail and be specific with our advice on that front.
Yep. Does the K-12 count as an air barrier for extra high wind zones? I don't think it's a specific testing.
We have not tested the K-12 as an air barrier, but the rain armor self-adhered insulation that goes over the front is an air barrier on their front. And then depending on what your wind zone is, we would look at your plans and provide a technical opinion and again a compliance pathway through with some other testing that we have to be able to meet your requirements and give you a letter for council specific to your project and your application.
Okay, I am considering from Jillian, I am considering using an in situ concrete or blocks for a two-story house. What is the most cost-effective way to insulate, interior or exterior? Do you have a cost analysis for this type of wall?
Uh, uh, Let me just think that one through for a moment. Exterior for cool therm needs to be under 10 meters due to the fire performance of the product and because we have not completed a BS 8414 in cladding structures for New Zealand, so a full fire test for cladding and so on. So I'm assuming our conversation is under 10 meters for the use of cool therm. Over 10 meters, I would be talking to you about different products that have a non-combustible status. Also within our portfolio, but not the focus of this presentation today, also continuous insulation though. Often with concrete block wall, it depends what your aesthetic is in terms of design. You might be going for more brutalistic construction, so you want the block wall to be exposed on the outside of the building, or in one instance, the block wall was used to withstand seismic activity, so it was constructed to withstand rockfall. In that case, the insulation had to come on the inside of the wall. And then the question that I would be asking you is, what do you need on that wall? Do you need a service cavity? Do you need a structure to hold TVs, mirrors, kitchen shelving, and so on? Because then we're choosing between either K12 with some form of cavity batten, service cavity or structure to support the weighted items, or K17 to give the thinnest construction but direct fix to the wall. So simply have an interior lining material. Those are the questions we'll ask you about your project, and it might be that 3 of the walls have got K17 and the one where the TV is hanging has a service cavity for the electrics, and it also has some structure in it because you've got a massive TV on that wall and the weight is beyond that of the clip and channel system. That is all part of the engineering process of designing that wall. We'll support and help you and connect you with our partners who might do the clip and channel design or the structure design as well. I hope that answers that question. If you'd like to send through your plans to technical at Kingspan Insulation for that particular project, we'll give you some conversation there. These products are sold through the building merchants, so the standard merchant chain, including Comfort Tech on that front. And so pricing can be easily obtained through any building merchant. And there is quite a range of commercial installers, which will be able to price both material supply and installation supply as well.
There's still a couple of queries. If everyone's okay with extending.
Yeah, thanks, Marie. If you do need to go, please go. We'll keep on recording and we'll answer the questions online. You will get a copy of the recording, so you don't need to stay with us if you've reached your time limit, but we'll just answer these last couple of questions.
Yep, okay. Is it necessary to tape the joints of K12 insulation board when used internally on a concrete wall to maintain the vapor barrier?
It commonly is. Again, it comes down to the designer's choice, but most commonly those joints are taped for a vapor control layer. And we have a variety of tapes listed on our data sheets that can be used within the Thermakraft family that have been tested for compatibility as well.
Can you confirm if Kingspan is to provide any technical advice on the batten fixings for a skillion roof with overlay insulation?
I can talk to you specifically about your project on that. We might ask you some questions about what your height limitations are, whether you want to do two 45 millimeter thick counterbattens. The first counterbatten secures through to the rafter, the purlin then secures to that one. Or if you just want a 20 mil for the first one, the purlin has to secure the whole way through to the rafter. The spacing of that purlin depends on the roofing profile and the performance testing done by the roll former as to that profile for the wind zone and so on. But more than happy to talk to you specifically about what you need out of the project and some of the other limitations you may have around height planes and boundary and how we might bring that project to light for you to meet those limitations. And often ventilation. I really want to talk about ventilation for skillion roofs.
Yep. Does the Thermocraft recommend any need for an additional underlay on the interior side of the wall, as some other underlay suppliers do?
Can I just ask that that question's fleshed out a little bit? I'd need to understand what construction methodology we're looking to be able to answer that in more detail. I will have your name here in the chat. I'm going to email you directly about that question answer so I can be more specific on that, if I may.
Yep. Yep. That one's from Peter Cresswell.
Oh, hi, Peter.
And then I'm from Stuart. Um, do through metal fixings not create a thermal bridge right through the insulation?
Not generally as you might think in terms of significant, as a screw is normally quite tiny. Normally there's an insulation washer used as well to spread that load of the screw. And I think you'll find in the standards they're not normally considered a major issue on that front. Again, we would talk about that specifically as to what might be specific in your project that would be a concern. And we can look at that in terms of our modeling software, which is ISO 13788 based, the glazier method on that front.
Does internal strapping and lining with continuous insulation negatively impact on thermal line at existing windows?
Mm, Morik, do you want to answer that for me in terms of an architect side?
Oh,
Does it negatively impact on, I guess
therm
that might depend on how the window's
it
been designed
windows, yeah, yeah.
and
Um,
and what type of window and how that window structure is. Again, that's probably quite a specific question. I think I'd need to see what you're planning there, and we'll talk through the window designs and the materials that we might have there as well. Um,
yeah, a similar question as well is where you show the timber around the window to provide fixing, is that not creating a thermal bridge?
It can create a thermal bridge. Again, it depends on how that window is set out and designed. That's an example of creating a hard edge to the window frame, which for that designer made it more simple to get the windows they had chosen into that frame. It can very much be a work in progress as to how the window is designed and how that structure is going to be put together at that stage.
Um, Give me one second. Where you show timber around the window opening, is it that's
I think we're in the
similar?
same.
Yep. What support does there need to be behind the insulation? A building a steel frame building with portals and girt space at 1200 millimeters. Will this be okay?
Cooltherm generally requires 600 mil support structure. We do have some steel framing details on our website already that we've put together. Um, but we would normally be attaching to the steel frame, and then the cladding is supported by that batten structure on the front. We have been having some conversation with portal designers with regard to granny flat style construction. And we have had NASH here, the National Association of Steel Housing, in our warehouse looking at some projects with a variety of insulation providers as to the best way to mitigate thermal bridging on a steel frame. So from that, we built out a series of design details for steel framing for walls, which should be dropping on our website now. And again, we'll specifically be able to look at your plans and provide some guidance on that one as well.
Timothy is asking, will these products be specified in the near future? And do we need variations if using these products? That should be
These
cool.
products all sit with a master spec specification now that can be found on master spec, and generally they are specified products because it is a often used where there's a particular R value requirement and a space requirement, and quite simply substituting for PIR does not meet either of those requirements. PIR will be thicker and less R value, compromising their design intention. So we do have work section support on master spec, so you can simply enter into master spec and send us the work section. The brand on there is Cool Therm with a K. And again, if you can't find what you need, just let us know and we'll be very happy to help you direct it to you. So you can send us a work section support and then we'll fill out the spec for you according to your plans. I probably better just take one more question and then get offline because we'll get told off for being online too long.
Okay, I guess last one from Ian. Have you looked at the figures where fixing K17 over existing plasterboard that has existing in wool insulation as a way to reduce thermal bridging?
Yes, yeah, very much so. That'd be one of the standard thermal performance calculations and dew point analysis that we'll do. One of the difficulties with existing construction is actually understanding what was built in there, because sometimes that glass fiber isn't well identified. So we might be conservative, and with your consultation, we might model something that we think could be much lower than's in there. We might give you a series of models that when that wall that you can do some judgment based as to what your decision is. Most often the cool therm on the inside, the K17, is not going to create any dew point analysis. It's where we have the outside that we might, and higher R values on the inside, that will start to really look at those dew point analysis conversations. As we've mentioned before, we love doing these kind of calculations for your project. They're really useful for council compliance. So just let us know and we'll do those for them. As I say, it's free. Just email them through, and that's what we do. I'm going to wind us up there just because we've been online for 45 minutes and I'll get told off for talking too long. However, if we haven't addressed your question in the way that you wanted it addressed, if you have other questions and we haven't got to your question today, please just email through technical@kingspaninsulation.co.nz. This is what we're here for. Very much appreciate you being online with us today to learn about continuous insulation with Kingspan. I won't see you before the new year. When we come out in the new year, we're going to be talking about our new early close system. So keep an eye out. We'll talk to you in the new year. Have a great Christmas break, and thank you so much for joining us today. Thank you, Marie, as well. Thank you, Pedro.